Hi everyone. Nice
Hello.
to meet you here. My name is Nikolai Vecchi, and I'm a director of Bioinformatics Institute and founder of Stepic, and I'm glad to introduce you my colleagues, and we will stream here today about Bioinformatics Contest. And this is Alexey Sergushichev, who is assistant professor at Moen University and head of Bioinformatics Direction in Computer Technology Lab, and Vitaly Aksionov, who is a researcher in ITMO University. And we will talk today about Bioinformatics Contest. As you probably know, it's still ongoing, and so for the first hour we will discuss mostly history and background and other unrelated topics which are unrelated to the finals. And next hour we will talk more about final problems and so on. So if you are still participating, please continue doing this. You will be able to watch this stream in recording. And now we will. I will ask my
Nikolai, by the
friend.
way,
Yeah.
just be patient because we can be a little bit laggy today. Not because of the contest, but the contest is still running, so we have to answer the questions at some point. So
Okay.
probably
Oh, that's
like
we will try to do everything.
we are the only two who are mostly answering the questions during the contest, so we haven't slept well I think during today. Alexei, just you slept from 12 to 8, but you waked up,
Oh.
woke up like several times during that and answered some question. That's amazing what
Okay.
Alexei did.
So we will go slowly. And if anybody online have questions, please ask them in a YouTube chat, and we will answer them one by one. And I will start with questioning my friends. So the first question is, who should and who can participate in the content? In the contest? What kind of background do people should have, and what kind of background is beneficial to finals and winning the contest?
Well, that's a good question, and actually we'll try to make this contest more or less, available for many people, like both from biological background, from computer science background, and so on. However, we try to do different formats of the contest. So right now it's mostly focused on computer science skills. However, knowing biology is still beneficial for understanding the problems correctly and more easily. So I think so it's more easier to get to the first places with hard computer science background and a bit of biological knowledge, but other people also can participate, and you also try to make this contest like at least some of the problems and parts of the problems to be solvable even like by hands. So even maybe very little knowledge, computer science knowledge, is required.
To be honest, I would say that their biology background is not really necessary here. If you're eager to know something new, you just can go to Wikipedia and read some additional information, and that is enough for you to understand the problems. Because, for example, 2 out of 3 contests was won by Gennady Karatkevich, who is not a bioinformatician. I think, kind of. He did his bachelor's and he did his master's.
Yeah.
On bioinformatics, but still he's not very knowledgeable in this area. I think he's doing more computer science stuff.
But I think it's always for us as a jury fun thing to watch the scoreboard to see who will win, just like computer scientists, or programmers or people with biological background. So I think
For example, we had an experience once on the second contest, which wasn't won by Gennady Karatkevich exactly. We tried to add more biological problem there, and computer scientists were draw back on this problem because it was very hard for them to understand what's happening there. And I think at that time their biologist won, right? on the second.
Bioinformatician.
Bioinformatician. Yeah, probably more bioinformatician. Unfortunately, we weren't able to come with another problem, another similar problem on another contest because like the problems are really hard to create and like we.
Yeah. But actually, if you look at the scoreboard right now, so I think the first person right now is James Matthew Holt, who is, I believe, is a bioinformatician, and the second place is Alexei Shmilov, who is not a bioinformatician.
He is exactly their competitive programmer.
Yeah. So I think we still have some kind of intrigue who will win today.
So basically, biology and bioinformatics background is not necessary, but it still can help. Or
we get a lot of questions this contest because probably this time our audience were more broad and we had more people qualifying from their qualification round to the finals, and we had a lot of questions kind of, I do not understand anything, please formalize the statement for me. Unfortunately, we couldn't have answered this to everybody because it will be unfair. You had to understand the problem to solve it. And kind of all the problems were understandable even for people without bioinformatics background. This was the first contest where we had the press-solving session this time, so we can get rid of a lot of problems with the tests and etc. Unfortunately, this didn't save us with the problems with the test, but we at least we could get that the problems are understandable. And there were no issues with that, at least.
But what do you think? Is it good or bad feature for bioinformatics contest that problems are understandable without biology background? So maybe we should make problems less understandable without biology background.
That's a complex question. How how we see the contest, and I think. Actually, it's always like a dichotomy for us. If we make it more biological, like to require biological knowledge, there will be a lot of questions that I don't understand the problem. But if we make it more computer science, so it will be more, not that interesting for people with bioinformatics background. So I think we'll still will be playing more with the format. But yeah, so it's not a bad or good thing. So
it's kind of bioinformatics are split into two parts. There are programmers that are going to biology and the biologists who are going to the programmers. Anyway, if you're a biologist and you want to learn bioinformatics, please go to the master's program of Alexei Sergushchev in ITMO. So it's a little bit of advertisement here. So if you're going to be a master's student and you're a biologist and want to learn programming, please apply for the master's program in ITM University. And if you're a programmer and want to learn biology, you also can do that at the same master's program. So kind of why not? Why not to advertise?
It was 1 minute of advertising. Just a random one. Okay, and next question is related to the previous one, and why some problems are quite far from real bioinformatics problems. So we tried various formats within the last year, like 2 years ago and 3 years ago, and this year. What's the difference between contest problems and real problems? What bioinformaticians solve in research, and why are they different?
Well, I think actually, so our problems, the ideas at least for our problems is not that far away from real biology. However,
biology.
Well, biology and bioinformatics, so they are definitely inspired by the real problems. However, making it into the problem that can be solvable in the format of the contest, makes it you have to adjust it somehow. For example, increase the sizes of the inputs so they are not becoming not that much real-wise, and or simulate some data that also can be not that real, and so on. So in general, we try to keep the problems relevant to actual bioinformatics. So yeah, but sometimes we have to like, shift a bit from that.
Can you tell a little bit about a history of like types of problems, what we had before, and for example, why we do not collect codes from participants? Why we do not run this code? Why we use data sets, for example, right now?
Yeah, so actually we tried when we tried to run the contest the first time. So we did the challenges where you actually have to submit the code, which would run on static and so on. And I think that made it too focused on people, like on the programmers, and actually not just in programmers, but on people who casually participate in other computer science programming contests. And actually, that's why we carry out this contest. Well, why we started it, because we had both some like research going on in bioinformatics and education in bioinformatics, but also our ITMO team is known for making also a lot of programming competitions. So that's why like our first competition was very similar in the format to standard programming competitions, but from that we understood that it made the contest too restrictive for the people. So we tried different formats and actually since the second one, the format is where you have to download some tests and submit some results. And I think it works more or less well. There are some problems like that we can't look at the participants' codes and so on, and that we can't make the datasets too big and so on. But I think it's it's a trade-off.
For me, the most interesting problems that we had previously in the the most interesting are the interactive problems that we had with the participants, where you had to submit an answer and the system gives you something back. And we had very interesting two problems in the first contest. Now we had the problem with the chemical reactions, where you had to understand which reagents you have to put there to generate you just ask the which reagents you have, and we returned you which reagents you have at the end, right? It was like that. And probably the most exciting really problem was about cows. Sorry. Yeah, like this problem was made by Alexei fully, and like it was amazing. You just have to submit 2 cows and they're breeding there and create a new cow.
Yeah, so we really like interactive format, which kind of standard for programming competitions, where your program has to interact with the computational environment on the server. So I think we tried it the first time, but
why don't we do it anymore?
Well, we tried to do it. I think we did these problems like this every contest except this one. But again, it depends if we have the kind of idea for the problem that can be made interactive, and whether it improves the problem or just makes it more complicated and so on.
Nice. Yeah. So, for example, next year will we?
And about the data sets, we were talking about the data sets.
Yeah.
Data sets are very hard to create, to make them bioinformatics as possible, because we generally had each year can we make a machine learning problem on that or something like that, and we always stuck that there are no open broad data set on bioinformatics.
Well, there are,
but
they have lots of errors and so on, right?
And they're open, so we cannot make they're typically open, and we cannot take we have a partners. However, the partners do not have this. We ask different universities. I guess we ask whom we ask. I think you ask somebody.
Yeah, we try to find some datasets that are not published that can be used, but actually
It's like pre-published data set.
Yeah, but having a good data set for machine learning is actually like costs a lot.
Yep.
And actually, I think like one thing that differs up, and actually there are some other competitions, well, kind of in bioinformatics that are more focused actually on these kind of problems that they have like single problem, and they gather a lot of data. They think a lot about how to measure the results of the participants, so on. But actually, like even making a single problem takes a lot of resources. So,
and maybe for real like bioinformatics problems for machine learning, we also need to understand how to grade the answers.
And actually,
it's not always clear for real.
Yeah, and if you usually don't know the true results, so usually people like for this kind of competitions, people try to come up with different metrics that can be used to score the results, but they usually not. There is no like ground truth and so on. So actually, it's not the thing that we tried to do in our case.
So.
By the way, if you have a very good data set,
yes,
and you can create a very interesting machine learning problem, then please contact us because we want to.
Yes,
we want to do this problem.
Preferably before publishing this data set openly, so we can use it on a contest, so all participants will be equal. That's also about problem formulation. So in bioinformatics, like a science, some part of this science is to formulate a problem. Basically, you have a like biological system. You think about how to formulate it in a more formal mathematical way, and so on. Is there any way to do this in a contest setting somehow? So, for example, I don't know.
Yeah, so I understand like what you mean, but one of the big of the problems why our contest is not like real bioinformatics, because in real bioinformatics you have some kind of weird question that can be formalized.
Yeah.
And actually, the big part of the bioinformatics research is to make the problem formal, which then can be solved the proper algorithm. And actually, there is some iterations that you came up with the formulations and came up with a solution. Then understand that this solution solves some different problem that you don't want to solve. So you modify the problem and so on. But well, you could make this into a contest, but this will be very unscalable. Basically, that's how I think. Partly that's what happens when people ask us questions. What about the problem, like what this part means, and so on. So they kind of try to understand the problem better. But for this, we need like human experience, like human to interact with. And it would be very demanding.
Yeah, exactly. Yeah, maybe for like we need to have multiple rounds and finals for 10 people, so we can grade this formula. It's hard.
But on the other hand, I think there are other competitions that can do this, like in particular like hackathons, where actually don't just have some general idea about what you want to do, but don't know the formal statement and formal solutions. So there you can tweak it a bit during the hackathon. And so in this, I think, and in this in our contest, like we just have some different area.
Yeah, so maybe it's a good idea for
so we cannot talk about the current contest, right? Because I wanted to
next,
do a remark about that.
No.
Because okay, let me say this another way. So generally we have NP hard problems in our data set. So it is kind of what you are talking about, because you don't know the solution to the problem. You haven't came up with the solution at all. You have to try different ways on how to make this problem feasible. So this is more like hackathon's problem, I guess.
Well, even having the problem in NP-hard problem is still like a formal problem, and having it.
Yeah, that's true. It's still you have to translate from bioinformatics.
But actually, this I think this relates to the first question about the background, and I think that at this moment when the format of the contest that it came out ended up, I think is a thing that bioinformatics actually I think that people in bioinformatics area should also think about the performance of the algorithms. So that it's actually on one of the recent conferences there was a nice talk about how much energy consumption is used for running bioinformatics tools, and actually it's quite a lot. So I think if every bioinformatician think a bit more about whether how his or her algorithm scales with the data, it actually will be very good.
Yeah, we still haven't done some parallel programming problem where you just parallelize kind of the test set and it will give you a better performance, because we kind of forbid using the clusters.
Yeah, we cannot do it in a contest because almost all participants should be equal regardless of hardware. Yeah. So basically bioinformatics contest problems are...
We had a change.
And actually...
We had a change in the first place.
Yeah, so Maxim Kovalchuk is now the first place. I think we don't know who is Maxim, and probably Maxim won't be able to reply us right now because he's solving some problems.
Well, looks like he's busy.
Yeah. Does Alexei Shmelov is getting near? Yeah, he's also trying to solve, because I thought that at the middle of the contest I thought that Alexei Shmelov will win because he solved the second, third, and fourth and fifth problem at all, and he was kind of with very good answers for the first one. And I thought, okay, he did it in 12 hours, so probably he can go to sleep and everything will be fine for him. But it seems that he woke up and understand that he falls out of their fifth place, even from the first fifth place.
Oh wow!
I think for me it was also surprising because I went to sleep, I don't know, at 8 o'clock or at 7 I think, at 7 o'clock, and I thought, okay, he was the only one at the top with all this. I thought nothing will change. I wake up and I see that there are 10 people with all the problems from 2 to 5th are solved, and the only division is by the first problem. I was like, wow.
Yeah, we will.
Wow, did we make the contest this easy this time? Because I'm really a little bit. I didn't expect that. I thought that the third problem will be the subdivision, their fifth problem will be a subdivision. We tried to make them much harder than it should be. Even the fifth problem, we added their hard version exactly, so there will be it will not be computationally solvable in the reasonable time. And we thought, okay, this is probably a good test for the split for the problems. But it appears not. The participants
not for our participants.
Yeah, the participants are much smarter than us this time, and I don't know. I'm really a little bit frustrated that the first problem is the problem that splits their competitors. Because previously in the previous contest we had several NP hard problems which you don't know how to came up with. Three out of 5 problems were with relaxed score, and we don't know about that. Probably this is because we kind of this time we had a almost full change of the ones who are preparing the problems this time. I think only Grigory Shovkoplas was the one from the previous contest who was done that, and this time we had more competitive programming people who are mostly very good in solving their precise problems, and probably that is why we have more precise problems this year than usual. because it was much easier for them.
Yeah.
Like they were much harder to prepare, because typically we prepare like for myself, I prepare the problems. Okay, so here is the test, like I generate the answer, and like, oh, that's the problem of the of the competitors to solve this problem. That is not mine. Like my solution gets like 10% of the problems, 10% of the points, and that's all. Like I don't care about that. And typically their participants were much smarter than me and solved like for 60% of the problems and so on. And this time their developers of the problems were trying to solve their problems on 100%, and they trying to make their questions so that they will be solvable. So they were kind of not very familiar with this type of problems. So in the third contest we had the same developers list as for the first and for the second, so they were kind of like, most of them were kind of already familiar with this kind of problems. And for this year,
So this is the third.
No,
This is fourth.
this is fourth. Yeah, this is the fourth contest, and it is not very.
But it's still,
It is not very kind of comfortable for them to work with relaxed problems.
Yeah. So we will try not to talk about this year contest for
Yeah, but
another
I
half of
think
an hour.
I haven't told anything this time.
Yeah.
Like I told only about the current scoreboard that.
Yes. So for everybody who's watching us, at first Scoreboard is under YouTube video, so you can go to the link and check the scoreboard if you still haven't done it before. And previously we talked about the background. Do people need computer science background or bioinformatics background to participate and successfully participate in this contest? Please share your background in YouTube chat. So please tell us what is your background. Do you think that you're a computer scientist, programmer, or a bioinformatician, or biologist, or somebody else? Maybe we will understand our audience and who participate in the contest better. Maybe we think that competitive programmers can win the contest, but in reality, a lot of bioinformaticians and researchers participate in the contest. While you share with us information about your background and maybe also write from what country, from what region are you, I will ask another question. What is the country distribution of the contest? So from what countries are our participants usually come from, and what regions and what countries? Yeah.
Sorry, we had a question like
Sorry.
that. There is some problem with typing of one the participant, and I don't know how to answer properly.
I can answer it. Yeah, but
yeah, I answered on that, but like.
Okay, so I need a 1 minute
Can you update
joke.
the page? Okay, yeah. Let me probably answer this question while Alexei is getting the hand on this. Okay, I have the diagram here. Yeah, which has the heading Kotri, not country, but Kotri. Okay, so but I think the data is fine, right? So
maybe
like,
it's some error in the data set.
I mean, this is not like the problem with the contest, right? This is
Who knows?
The data is fine. I hope.
knows?
Like
Who knows?
just the. Just
well,
the heading is right.
I think it's from like web analytics, so it can have some
Okay,
errors.
so we have 35% of the participants are from Russia.
Oh, that's.
I don't know why. I don't know why. Because
and I think that's because of code forces.
I don't know the real reason. Because like, and only the next country is 15% by India.
Mm-hmm.
I'm a little bit confused because I'm a little bit confused why Russia is on the top, because so much in the top, because we kind of mostly advertised it through the Rosalind and
In previous contests.
previous contests, and I'm kind of I'm
Yeah.
kind of confused that there are lots of people participating from Russia there, because Rosalind is an international project. What do you know their distribution for the Rosalind? Probably in the Rosalind, like
It's like a
35%
regular-
is
yeah.
Russian.
I don't have it right now, but I think it's like a general population.
Like
My-
general population.
Yeah, maybe about a little bit more Russians, because historically, since we are from Russia, we like, people around us use Rosalind and so on. But I think the most popular country is US on Rosalind.
The most popular
Yeah.
country is US.
Yeah.
Okay, so then I have no idea why Russia is on top. Like we advertise it on Codeforces, but if like the most number of participants on Codeforces are from India.
Mhm.
So
this is
I
the
would,
second country
yeah, this is the
this
second
year.
country. So
Yeah.
I would expect that India will give more people than Russia. So I still can't explain why Russia is on the top. Like, do you have any ideas, Alexei?
I have an idea. Maybe Yandex, who is our partner this year, they made a press releases and announcements about the contest, and Yandex is well known in Russia.
Yeah, and
maybe,
actually, I think the
Russian
participants who
users.
can hear us right now can answer where they came by our contest. So where did you learn about it?
Yeah.
And the people.
Russians forward, Russians forward, Russians forward. That's like Russian,
No.
Russian, Русский вперед. You know, like that's.
Yeah, that's interesting. People in the chat say that.
Oh, there's
One
there's
is-
some people in the chat.
Yeah. One person is biologist, going for bioinformatics from Italy, and he or she said that it's hyper hard. So the contest is quite hard for biologists.
I guess this is true. This contest is very hard for biologists, since we don't have much problems exactly on biology. This time I think we didn't even require to know. Like, we put everything in the statements. I think all the
biology
biological stuff we put in the statements.
Should we do the opposite next year? Like put all computer science stuff in the statements, but not
Yeah,
biology?
but this will not end very well. Like, because on the
Yeah.
on the second contest we put the biology problem, and we get so many frustration from the participants that time. So we decided never do like. However, if you have a very nice biology problem, please write us, and we will be happy to take this problem for our contest next year or in the next 2 years. I don't know if we will have enough force
I
to
hope
make
we
like
will.
they're like 1.5 year that is gone from the previous contest.
Yep.
And like, I don't want to say exactly. No, I want to say exactly why we didn't have this, why we had this problem, because we came up at the September of 2020. I think it was already 2 years ago almost, when we were decided whether we were going to make problems for the contest. And after the third contest, like after how we prepare, like the preparation of the contest were like pretty lengthy, coming a length each time, because in the first contest we came up with this idea like in 1 month, and we did all the problems in 1 month, and like we came up with the ideas of the problems in 1 month. We were like, wow, we can do that in 1 month. There will be no issues. On the second contest, like we understand that probably let's give us a little bit more slack with creating the problems, and we were like we spent 3 months on creating the problems. And we were okay, we're getting where this tendency is going, and we're like, let's start the next contest in half a year, and we came up with the problems only like in 5 months. Like, we take 5 months to create, like, to came up with the reasonable problems. And then we understand, like, we have 1 month, 3 months, 6 months. Oh, the next will take 12 months. So probably we will not come up with the problems for the next contest, because we were really...
Should we start tomorrow?
Yeah, this is kind of like that. So if we will start to, like, and this time we came up with the problems in 1.5 years. Really. So like that the next
So
time when we will count the problems, it will come for 3 years. Like even if we start right now, the next contest will be in 3 years, and I cannot do anything about that. It is like how it is. And even that we started there thinking about the problems for 1 year and a half, we still didn't have problems like by the like.
So maybe it doesn't
like-
matter. So we can start like 1 month before the contest, and
Like,
everything will be the same.
Before the qualification round, we came up with the problem like 2 weeks before. Like the last problem were created 2 weeks before because we cannot come up with the problem. We were dry. Like, and we like. Actually, this becomes the problem on this contest, the third one. Yeah, we had like with the qualification round. This was very very interesting. You probably you like the participants of the contest were find out that their first problem on the qualification round was very similar to the problem from the final round from the previous contest, and that is no coincidence. So we decide like to help us to create with so many problems, with the problems, we decided, okay, we will take the problem from the last contest that had not very good scoring, and we will take this problem, make a proper scoring, and put this problem on the contest. And we were like, okay, we give this problem to the person, and we said, please come up with their scoring for the problem. And he spent a lot of time trying to understand the scoring of the problem, and he hadn't come up with the proper scoring. And we was like, oh, like it was 2 days before the contest. We was like, oh, we have a problem here. So, and in rush, we decided to simplify the problem, like because we thought that the problems for the qualification was not simple enough, and if we simplify this problem, everything will be fine. And we did this problem in like 4 hours or so. I think this was not very good experience, I wouldn't say.
So we will later on we will describe how everybody can submit problem ideas and help us with
Yeah,
this
but
really hard issue.
we're like in so hope that everybody will see that we do not have the problems. Like, we even like it's kind of we decided to make the bad contest like for kind of bad. We didn't exactly do that for specifically, but I mean, from my perspective, the problems are worse than in our third contest or in the second contest. From my perspective, probably someone said that this is not true and the problems are much better, but from my side, they're worse. And like, so that people will not, like, and we spent 1 year and a half to create this problem. It's like, you should understand that it is really hard to come up with the problem. So please don't like blame us for this. We really try to do that, and probably help us with coming up with the problems. I think we will post the link to their Google form.
Yeah. So we will.
Oh, sorry. Like Alex Sage, you could have just tell Vitaly shut up. Like, like that's their.
We will definitely describe how we can help us with the problems, and looks like we need to just use 1 month instead of 1 year and a half next time, because there is no difference, and 1 month is
No, there is.
enough.
There is. We tried to come up with problems in the September.
Yeah, I remember. Yeah.
And we had like kind of their approximate problems for in February, I think we were done.
Yeah. So we are switching to the next question about industry and bioinformatics in industry. So why bioinformatics and bioinformaticians are interested by industry, and what kind of industry use bioinformatics as a part of their businesses or sponsor this contest and so on.
Well, I hope that we will hear soon from the actual, like from our sponsors. But
shouldn't it the good time to say who's our sponsors are?
Yeah, actually,
Yeah.
so I think, well, let me say that first, I think that right now the bioinformatics is kind of hot area for software companies because biology is now it's just people say that there is a center of biology or biotechnology, and there are a lot of data, and actually it's a good time for software companies to get into this area, and so we have several sponsors of this contest, and well, we have first of all we have JetBrains who supports Bioinformatics Institute for a long time, and our group at Mo and so on, and they do a lot of great software tools and actually support research in different areas. There is also a Sirocco company, which a small, maybe not that small startup that also tries to now go into bioinformatics, and yeah, there is Genotech, which is a Russian genetics company. Well, for them it's obvious why they interested in this. And the last one is Yandex, and I think we have a person from Yandex on in Zoom. No, we don't have it.
We have it or we don't have? Let's go to the sponsor, I guess. where he is. Please show me
1 minute.
him.
1 moment.
2 moments?
2
3
moments.
moments? Okay, by the way, Nikolai, there is a problem with the stepping in one of the participants. I don't know what to do in this. It is sad for him that he cannot send your submission, check internet connection and try again. And his file is 88 bytes. It's not 5 megabytes. I don't know what we can do in this situation.
I don't know what we can do right now about it, but you can ask this participant to send this submission by email, and we will. In worst case, we will grade it after the contest.
Okay.
Yeah. So we are connecting our partner Yandex to this video call.
Hello. Can you hear me all right?
Hi.
Yeah, hello. How are you?
Yeah, I'm great, thanks. How are you guys?
Good.
Yeah,
good.
very good. Very good, I would say.
Yeah, so can you tell us a bit about Yandex and why Yandex support this, and in general, what do you think about this contest?
Well, the TLDR version would be even though, to the best of my knowledge, Yandex doesn't have a bioinformatics division, we still find these problems, extremely relevant and very closely resembling what we do on a daily basis. And I would like to elaborate a bit more on that. So a couple words about myself. I work at Yandex and I lead the team that we call the base search development. And basically, we're responsible for the core component of the Yandex web search, which is namely the index and basically a bunch of files size of several petabytes, and the runtime that sits on top of that index and responds to search queries. And yeah, how that's relevant to bioinformatics, I can explain easily. I can start with a bit of history, probably not so long ago. Remember, 5 years ago, everyone was talking about big data. This was big thing on all the conferences in the news. Did you guys saw that stream of information in your part of the world?
Yes, and I think actually one of the reasons why this kind of contest can be interested for not standard, but data science companies, because bioinformatics, because it's some kind of skill that just how to work with the data, how to process it. So while it's maybe not directly relevant, different still for the people to be able to to answer these complex questions about the data that may be very relevant in this case in particular.
Yeah, that's where I'm going. But I would like to tell you that big data as a concept is now obsolete. You won't hear it anymore, neither in the news nor on conferences. Well, at least that's my experience in the past, I think, 2 or 3 years. So I think the concept was like if your data doesn't fit into RAM of a single machine, that's somehow a game changer. It's a completely different story. You need to do things differently. But this particular limit, I don't think it's well, this is inconsequential. I mean, the amount of RAM that we have is growing every year, and distributed storage and compute systems are now a commodity. And if you have like petabytes of data, hundreds maybe of petabytes like we do, you can easily process it if you can afford the compute power. It's not a big issue anymore. It's just, if you can buy the compute to go and do it. But I think there is still a very hard limit on a size of data, which is much harder to move, and that is the amount of data that a single human being can, digest. So, and that is not going anywhere because human brains are unfortunately not growing exponentially with every year. And distributed human systems, like I can tell you as an engineering manager, are much harder to deal with than Paxos. I would better deal with distributed compute sometimes rather than with a team of 5 engineers. So yeah, I mean, if you have lots of data like you guys have in bioinformatics and you want to draw any conclusions from that, you first need to convert your big data into small data, which does not only fit into the RAM of your laptop, but fits onto the screen of your laptop, which is much harder problem. And within that space of data extraction, there is a very important subclass of programs called search and ranking. And then I think this is where we have lots in common, the Yandex search and bioinformatics, because in many ways, the many problems that you guys have, I looked through the definitions on set. Unfortunately, I didn't have a chance to participate myself, but still, they closely resemble the full text search, except that instead of like normal words and text, you have this ATCG nonsense. Oh, sorry, not nonsense, but still. But other than that, like you need to look for patterns. You need to identify patterns with some margin of error because there are errors like for many reasons. So sometimes it's not errors, but meaningful changes, mutations, words change over time. There are morphology in the languages. You need to take all that into account. And search and ranking, like it's everywhere. For instance, everyone thinks about Google or Yandex, but it's also about Netflix, for instance, because recommendations are also the same class of problems. You have many items and you need to identify top 10 most relevant for a given query, but that time the query is not like words, but rather the user profile and his interests. Or if you take commercials, again, the ads business, it's the same. It's just like your the query again is the human profile, and you need to identify top relevant things that he are probably going to buy. So yeah, like many people in the industry says like, oh, all these competitions, they're so irrelevant, nothing like the real world programming is like that. And in a way, they may be right because many companies face very straightforward problems like copying JSONs from one database into another. Maybe they don't need that much of algorithms, but that's definitely not the case with Yandex. I mean, we face hard problems every day, and hard not only in terms of coding, but I mean scientifically hard, mathematically hard. And we employ best engineers we can find to solve them, and still we're always short on engineers. We can't find enough. There are lots of problems just sitting there, waiting for someone to come and solve them. So speaking to all of the bright people who are listening now, who participated in this context, I mean, if you're good at bioinformatics, there is absolutely a good place at Yandex when you can employ your skills. Even though we don't do much, bioinformatics per se, we just solve problems that resemble so in a way. Yeah, and you guys can get my contacts from organizers. I'm happy to talk with you if you're looking for a job, and even if not. But yeah, it's a minute of sponsored message.
Thank you for sponsoring this year's contest.
I still have the question though.
Okay.
You talked about recommendation system. When you will be able taking the genome to understand the recommendation for the person? You just take the genome of the person.
Soon, sounds like a dystopia, but I won't be surprised. It's gonna be, I think, maybe 20 years or something like this. But imagine how much. Yeah, imagine how much laws are going to be around that, like how we treat the data and how we collect it. It's going to be a nightmare. I mean, like it's already a nightmare with all the personal data. If you add the genome into the mix, it's just going to be extremely, hard.
You need not only genome, you need transcriptome and metabolome and other omes, and that's a lot of data and a lot of interesting problems to solve.
Yeah, I think Vitaly, you should join us, like because this is definitely sounds like something we can do in the future.
Yeah.
Your knowledge is gonna help us. Yeah.
Awesome. Thank you.
Thank you.
Thank you for joining us, and thank you for sponsoring this contest.
The pleasure is mine. Nice to meet you guys. Bye.
Nice. Bye.
So we have about 10 minutes left before the final
We
round
have a
is
huge
over, and
we have a huge rivalry in the scoreboard.
Yeah,
what's going on?
Maxim Kovalchuk is still in the first place. It's about like 80 points difference from the second place. So I think actually let me try to see what people are trying to solve.
We have Louis C. in the 5th place. Somehow, like I haven't seen him before.
Well, people are moving.
People are moving, so like that's like I know 2 persons for the first 5th places. I know Alexei and Zahar. Like, that doesn't mean that I gave them the problems before. I just know them.
Yeah, actually, like we like always look for the participants, and in particular, so some of the names are very familiar, and like the James Matthew Holt, for example, who is like on the 2nd place right now. Well, he was in the 2nd place, I think.
Last time.
Like,
2 years ago.
Yeah,
right?
3 years ago. Like
3
one before that.
3 years?
Yeah.
Oh, okay.
Well, the Yakovlev also participated, and I think he got like 3rd place the last time.
So experience
Like Jeffrey Ho is
matters.
also like one of the participants, former participants, and so on. So actually, that's great to see some familiar names. I don't know, we don't know how you look like, so just names for us.
I know.
Hope at least like participants right now can see at least how we look like. Maybe actually, I hope that some of them will join us today in the 2nd part, and maybe we'll be able to speak with them. So.
I also know S. Yuri. Like I don't know him precisely, but I saw his nickname several times in the previous contest. Like Max Balsels, also Balsels. But some of the names are not familiar for me. Like John Smith. Who would guess that there will be John Smith in the top?
Who knows? Who knows? Yeah.
The person with the surname Smith.
Yeah.
Yeah, but the people who are not here are like, for example, Gennady Karatkevich and Nikolai Budin, like the winners of the few of the last contests, who actually joined our like jury team this year, and I hope that some of the this year participants will also like follow this example, so that it will be easier for us.
I could say the story how we hired Gennady Karatkevich.
We have only 7 minutes in this part, so you can tell
the
story later. Yeah. So in this part, we still have some topics to cover in 7 minutes. The first topic is I need to remind you about our prizes. So this year in this contest we have very nice prizes for winners of the finals. And the first prize will be whole genome sequencing from our partners, and we will know who will win this prize a little bit later. Second and third prizes are whole exome sequencing.
What is the difference between whole genome sequence and whole exome sequence?
So exome is a part of it's mostly genes.
It's a part of genome.
It's a part of genome, but not a whole. Yeah, but it's whole exome or whole genome. So whole genome is everything, including some garbage and exome.
Okay.
And whole exome is like genes and everything what is like like most
Why you need
most
whole,
meaningful
why,
part
why,
of the
why,
genome.
Why you need whole genome when you need just only whole exome?
Well, because I think it's still not clear like what matters and what doesn't in the genome. So while you have a whole exome, I think it's I don't know, it's about like 5-10% of.
1%. So
But whole exome sequencing, I think it's
Yeah, but the rest
1%
is-
only.
1% of the genome.
Okay.
It's
But the rest is garbage.
pretty-
No,
the rest is not
not
garbage.
always. Not
So
always.
actually,
It's
this is-
unknown.
So this will be like a good exercise for the people who will get this
The first prize winner.
prizes
Yeah.
for the first prize and the
Yeah.
second one actually
Yeah.
to analyze and interpret the data,
Yeah.
because well, people are not that good, sadly. Like it's like 20 years from the first like human genome sequence, so but we're still far away from fully understanding what what are the consequences of the mutations in the genome, like non-coding parts and so on. So
Yeah.
So they
well,
can move their science forward.
Yeah.
Like, this exactly.
Yeah,
trick.
and also I think with whole genome you can better trace ancestry because maybe some parts of the the
Okay.
genome doesn't matter. But
And about ancestry.
yeah,
Yeah, right. The 4th and 5th prizes.
yeah, the fourth and fifth prizes, 5th place prizes are 23andMe or Genentech's DNA service. It's I think it's about 1 million points in a genome, so it's like smaller than exome, but it's also like most meaningful points, most meaningful SNPs in a genome. So first place will get a whole genome, second and third place will have a whole exome, and fourth and fifth place will get 23andMe or Genentech services, and all other places up to 30 will get our Bioinformatics T-shirt. So if you're on a 31st or below, try. You have 3 more minutes and try to be.
As you can see,
in-
we're sitting in Bioinformatics Contest
Yeah,
T-shirts,
from
like from
different years.
Different years. I think Nikolai's
Yeah.
was the first.
Yeah.
Alexei is the second, and my my is 18. Yours is 19.
yeah.
Yeah.
Well, we have
Yes.
here.
Yeah. Yeah.
So you are the best, Alexei.
Yes.
You're the newest.
Newest.
The latest.
The latest, yeah.
So yes, that's
And
our
like
prizes. Yep.
their organizing team told that their new T-shirt will be amazing.
Yeah.
So like
But
that,
we will not
that-
show you today.
You have
so
two
it's,
minutes to get your T-shirt.
So we will not show you the T-shirt today, but yeah, we will see it
Yeah,
later.
but you will be able to like receive them
Yeah.
and post the photos like in
Yes.
social networks like Twitter and Instagram,
Yes.
so that the other participants can.
Also, all the participants will receive the certificate.
Yes.
By the way.
all finals participants.
All the
Yeah.
participants in the finals.
Yeah. So everybody who participated in the final round will get a certificate. We will send you in a couple of weeks. So my last question is about the problems. We already discussed how hard is it to create a problem set, and each year we try hard to come up with ideas and data sets and so on. So please describe me if I want to contribute to the problems next year. What should I do? Where should I submit my ideas? In what form? What kind of help do we expect?
Yeah, so on the website of the contest, I think.
And under the YouTube video.
Yeah, and under the YouTube video, you can find the form for the submission of the ideas for the problems, and this is like very important form. However, I think that many people can provide the ideas, and the thing that we are looking for is not just like comments like that we had some machine learning problems, but actually some kind of ideas. And because for us, like what we have to do to have a like proper problem, we have to some kind of idea of how like biological idea of the problem, several like ideas how to solve it. Of course, we have to simulate the data and how somehow score the results. So this is like one of the most complex part, because the data should be, well, there should be like ground truth so that we can score properly the results, and so that's why like more, and like as we discussed earlier today, that's like in real bioinformatics you don't have like formal problem, and you try to and you actually get to the formal problem after some iterations. So yeah, this is actually what we try to do for the contest. Still, if you have some kind of idea about what kind of data should be used, like what algorithms can be used, how you can simulate, maybe how you can solve this, and so on. So that's what you should submit. And yeah,
and there is something you can get the Bioinformatics T-shirt
for free, like just for providing.
Just for providing the problem. Yeah. Probably you will get something else, but we have to discuss this more privately.
Maybe you will also get a fame and a lot of appreciation from us. And the last question from the chat is maybe we will. That's by the way,
that's the end of the question. Still, let's answer the question, and then we will.
Yeah. So the question was about problems of this year, whether we will explain how to solve them or encourage winners to share their solutions and so on.
Yeah, we just encourage everybody to share. We will at some point, probably in 1 week, we will open, as in the qualification round, the last step where you can discuss their problem solution, and I encourage everybody who gets there some reasonable number of points, or even not reasonable, to share their solution, like their ideas for the solution with other peers.
Yeah, because actually, while we have some ideas how to solve these problems, actually, for some of the problems, the participant score points are much higher than we had in the jury. So actually, it would be very interesting for us to know
how they did it.
Yeah, how did you do that? Like
and we do not collect code this year, so we do not know. Maybe. Yeah.
But I think.
So yeah, the final is over, and we are making a short break, about 5 minutes in the video translation, and please join us in 5 minutes again. So we will discuss more on this final and about this contest. Yeah, thank you.
Hello everyone. Hi again. My name is Ekaterina Vekhi and I'll be here for the second part of our stream. And I'm from Bioinformatics Institute, Russia in St. Petersburg. And I also want once again to introduce two persons that are here with me in the Stepic studio. In case you just join us, because the contest is just over and we are really hoping that more participants will be joining us in this live stream, and maybe we'll talk with some during this conversation. So here it's Alexey Sergushichev, assistant professor in Etmo University, and Vitaly Aksionov, researcher in Etmo University. And they are co-organizers of the contest, and they coordinated the problems development. So we're really glad that, I hope some of the participants are watching, and we're really glad that you joined us this year and take the time to participate in this challenge. And I guess now we're going to look in a scoreboard, and I'm really excited because it was like the competition till the last seconds. I saw submissions very close to the deadline, and I just want to give one remark that we will take a week to finalize the results, and we need to check that everyone followed the honor code and that followed the rules of the contest. But we will talk about the leaders for now. I think we will start with the top 5 of the scoreboard. So Alexey, maybe you announce who are the leaders right now, and I also will be checking a bit with my monitor here and about who will join us next. So who are the leaders?
Yeah, so let's start from the 5th place, which is Louis C. Sorry if I misspelled your name, and actually maybe you will join us and will say how to pronounce your name properly. And the 4th place is Zakhar Yakovlev. I think he's also from ITMO.
Didn't he get already 23andMe previously?
Well, the 3rd one is Alexei Shmilov, and I think he's from Nizhny Novgorod.
Nizhny Novgorod, yeah.
Well, the 2nd one is James Matthew Holt, which is again probably again the 2nd place from James. I hope you will be able to participate in the next contest.
I was really supporting James, and I hope to see you next time.
I hope to see you as a problem author next time, to be more precise.
Yeah, that's true. That's true. We really want the top participants to join our team, so we have awesome challenging problems for the next contest.
Yeah, and in the 1st place right now is Maxim Kovalchuk, and I hope that it will stay the same. So I think we'll preliminarily congratulate Maxim for winning this contest.
Yeah.
And
the only thing that can happen is their cheating procedure that we have to find.
No, we hope that everyone was fair, and
yeah, we hope that everyone. Yeah, for sure.
We just needed to make this comment to make sure that everything is clear. But we hope that the scoreboard stays the same.
Yeah.
No, I'm pretty sure that it will stay the same, but we still need to have a week to finalize the results.
Yeah, and actually, if you are among the top 10 participants, our team, the contest team, is contacting you right now. So please check your emails and your spam folder in case. And we really hope that we can connect you via Zoom.
Yeah, we really want to talk with you.
Yeah, we want to make this part a bit more interactive, so it's not just us talking about the problems and contest, and we want to know your experience, like what was it like to compete, and please join us. And I think we will talk, while we're waiting, we will talk a bit more about the problems, like how they created, and we dig a bit into details about what was in this final round. And the first question I want to ask Alexey, he's the author actually of the first problem. And what the idea stands behind this problem? Did you come up with it during your bioinformatics work, or?
Well, this actually seems that the problem that divided the top participants, and so and this problem actually very like bioinformatics, like from the real world. And the question is, how can you impute some missing data from the genomes? And for example, the people who are like from the fourth and fifth prizes today are genotyping, like microarrays, which gets you just like a million or so points of your genome, as opposed to, for example, like whole genome sequencing or whole exome sequencing. And the question is, can you get some more data from beside this million points from these microarrays to get like more full understanding of your genome? And this is exactly the problem that is solved, that has to be solved in this genome imputation task. So basically, the idea that some of the, like, why we can actually do this is because the like mutations, like our DNA is inherited, like actually inherited, and like not randomly, but in some kind of structure. And for example, the like close positions in the genome are inherited together. So for example, if you have like A at the first place and like T at the second place, from like in one person from population. So and we could guess that the second person also has the like A at the first place. He likely will have this, I forgot, like T in the second position. So basically, that's the idea, the general idea, and it's actually took like a lot of, I think there was like a big project called Haplotype Map project, like I think in 2004 and 5, that we gathered the data of how this genetic information, how the structure of the inheritance looks like, and actually this is the data that we used for this problem. And so basically,
So it's a real data.
yeah.
Right?
So well, the data is not real, but it's simulated based on the real data. So the structure, actually, the structure, and so the like for us as the developers of this problem, the task was to select like the proper, like the interesting regions of the chromosomes that has this interesting structure. And I think, and so this problem is actually based on one of the most complex structure in the human genome, like from the correlation, like position correlation perspective, which is this MHC part of the genome, like based on that codes the immune system. So, and there are a lot of interesting parts there. So, and based on this, we generated this data, and I hope that participants had some fun to like solving it. And actually, we don't know, like, well, people in general know how to solve it. Like there are some approaches how to solve it, but I hope that if some of the participants join us, they will tell us how they solve it for this high amount of points.
I think, yeah, the results are amazing in the sense
Yeah,
that,
yeah,
that our solution was much worse.
Please join the contest team and tell us maybe today, or if you can join us today, maybe share in the comment section in the discussion step, like how you managed to solve it. I think, do you consider it was a hard problem, right?
Well, it depends. So like getting some points is relatively easy, but getting like a lot of points is like was really hard.
By the way, our most longest fan, David Eccles, wrote that he liked the problems. So if you like the problems, please write it. We will be really happy. If you don't like it, also write to us, at least by email, so that explain why you didn't like the contest. We will have the feedback form, right?
Yeah, we will have the feedback form, but we are all here now, so we will send the feedback form in a bit. But yeah, please share, and yeah, if you like the problem, so the contest, also share. It will be really glad to hear. And I'm just gonna check a bit who will be joining us next, because we have several authors of the problems who will be joining us via Zoom. And just a second.
It will be on
So it will be German, right? So I'm really glad to introduce you German Demidov. He is the author of the
of two
problems. I think the one maybe for the qualification, right?
Yeah, like one
for the
qualification problem
qualification.
and one for the...
Yeah, and he's the author of the second problem, causative mutation.
Yeah.
So, German, hi!
German, hi!
Great to have you here. And German, please tell us about like the biological background behind this problem. Like, how did you come up with it, and maybe like, did you come up with it during your work, or just some more information?
To be honest, I work in medical genetics in the institute in Germany, and to be honest, this is basically the problem that I faced once during my actual work process. So we had one large family. Like a whole genome sequenced large family from Sweden, I think. And we performed all the different types of analysis, and we weren't able to find the cause of the genetic disease there. We had like a family tree similar to what we had in the contest there. And we still weren't able to solve it. And then we had to apply this technique, this mapping of the like finding the location of this causal variant. And I had a really bad time trying to find the solution. I'm really interested actually how the participants of the contest solve this problem. I really would like to see the solutions, because my solution wasn't really, probably it wasn't the best. I would like to see what people here in the contest did with this.
Yeah, I think us too. So please share your solutions once again, and in the discussion step, or join us in this studio online and share how you solved the problem number 2, who German was the author. And I think, thank you German, it was great.
We don't want to talk with him about the qualification problem, how he came up with
we can, you can ask a question.
German, how, like, you had the first qualification contest, the problem, how did you came up with that?
And actually, so I think there was some comment that it's not that biological, but I believe that is like pretty real world problem. So can you comment on this?
Yeah, I saw this comment. Yeah, it was interesting comment. Thank you for this comment. But it's actually a real problem there. So it's not that we just reformulated computer science problem and pretended it to look like bioinformatics. It also appeared during the work, during the medical genetics, solving of medical genetics problems. We have diseases and we have patients, and sometimes like we need to automatically match between them. And this is like, this problem is absolutely legit, and we are solving this now, working on the rare disease cases there. And current solutions are also quite imperfect there. And maybe I should also visit the forum, maybe look how you solve this problem. Maybe I can adapt your solutions for our practical problems.
There are a lot of people who shared their solutions in the last step. So if you want, you can check it already out.
I should send me the link, please. Yeah, I will definitely check this. Yes, thanks to all the participants. Let's see if your solutions, how they work in practical sense. In a contest, we simulated all the phenotypes. We simulated this, but in general, this actual tree of human phenotypes, it's available online, and you can go to the Human Phenotype Ontology's website, and you see how it's organized. If you the tree of disease phenotypes there, you see how it is in reality there. You can compare with what we had simulated with what we had in real life, and you can try also. Yeah, the participants may try to solve some real problems with this. This problem is very, very like cutting edge, more or less.
Yeah. So like if you want, so you can find the contacts of German, I think, somewhere, and send help to him to him. Yeah.
Yeah. So now we see that it's a real biological problem, and thank you for sharing your ideas, German. Bye bye.
Thank you very much.
Thank you for joining. And I think we have the authors of the next problem here, and I just want to say that we saw that several participants were trying to connect. Please try again, and we will be talking to you right after this discussion. So don't give up. We see you, and just just don't break the connection. So now we're going to be talking to Andrei Prozhabelsky and Dmitry Silutin, if I'm not mistaken.
Yeah.
They're the authors of the
Fifth problem.
problem in the final round. Let's hear them. Can you
hear us, Andrei and Dmitry?
Yeah, sure.
Yeah, I think Andrei is the author of the idea, and Dmitry helped to create the problem. So Andrei, tell us about a bit more about the problem, like how you came up with it and what's it about.
Okay, actually, this problem I've been solving myself in real life, and I've been working on it for probably half a year. Of course, not only this problem, but this problem as well. So a bit of biological background. As you know, central dogma of molecular biology tells us that we have DNA, which we sometimes call a genome. It produces RNA, and RNA translates to proteins. Now, in higher eukaryotes, in complex organisms like mice and humans, genes produce RNA in a very tricky and complex way. Imagine you have a book of recipe, but depending on your mood, you may skip some of the points in the recipe and you say like, I go first, third, fifth, seventh, I skip number 2, number 4, number 6. And that's exactly what goes in the genome, in the genes of higher eukaryotes. They contain exons, which are coding parts, and the resulting RNA can be a combination of these exons. So it's not necessarily goes in all exons, all coding regions go into a transcript, into an RNA molecule. It can be a combination, and they can skip exons, they can include exons. So this is where the problem comes from. Now, of course, as we scientists are very curious, we decide to sequence not only genome, not only DNA, but RNA molecules as well. And new technologies allow to sequence RNA molecules almost perfectly from one end to another end. But almost means not completely. It may lose some parts on the ends, some nucleotides on the start, at the end, and it may sometimes contain sequencing errors, which lead to incorrect detection of these exon coordinates. And this is exactly how we decided to do this problem. You have an input set of exon coordinates, which may be fuzzy, like inexact. They may be truncated on their ends, and you have to match them to a set of reference transcripts, which, of course, for mice and humans, the reference set is already known. So the goal is to detect from your particular sample what kind of RNA molecules you have there comparing to the reference. Briefly, that's it.
Problem number 5 is a formation, just for those who maybe just join us or want to know more about which problem we're talking about. And Alexei, Vitaly, maybe you have questions to Andrei about the problem.
Yes, so do you have the solution for this problem? And actually, did you try maybe to solve it in this formulation that we had?
Unfortunately, I haven't had a chance to solve it in this formulation, which is more close, I guess, to computer science, more formal one, because, yeah, of course, in biology doesn't tell you the formal problem. So, no, but I think if the problem will be available later, I will try to do that. Of course, what I did, I tried some kind of heuristics, which suits best to the real data. What I did, I generated some data sets that look like real data, real sequencing data sets. And then I tried to, when you simulate the data, that means that you know the ground truth. So I tried to tune some parameters and tune my heuristics so that it gives kind of optimal results for the data set I had. The second thing is that you may, in biology, it's not always good to give an answer whatsoever. As far as I understand, in a computer science problem or in the contest, you have to give an answer whatsoever, the closest one. in biology, sometimes it's better to not say anything than make a mistake. So my algorithm, to say it's somewhat precise, but it may not give all the answers. So this is what makes it more biologically applicable, I would say.
Yeah, and
it would be interesting to see how.
Yeah, so maybe can a bit comment about the size of the inputs. So now, like for this problem, like in the contest, we had input about like 5 megabytes and output of 5 megabytes.
25 megabytes.
Yeah,
and our one input was 60 megabytes, which was compressed.
Yeah, but I think like in your daily work, it's like much bigger datasets, right?
Yes. So there are two inputs. There is a reference set, which you match against. For example, for human genome, you have approximately 20 to 25,000 genes, depending on which reference set you are using. Each gene might have 1 to, I guess, approximately 100 different isoforms, and up to 100. These isoforms contain up to 100 different exons. I think 100 is a somewhat a limit. And for the input data, you may have, I would say, up to 70 million inputs. Like a typical nanopore run, it's a technology for sequencing both DNA and RNA. You may have, up to 70 million reads per run. Which translates, of course, into 70 million inputs. So yeah, input can be much larger, but the complexity of reference set, I guess, is somehow lower than was designed in the contest.
It would be great like if the participants' solutions will help you in your research to make your algorithms better.
Yeah, exactly. I would be very interested to see what they pose, because as far as I know, not many people tackled this problem so far, and it's been a problem that is being solved by science right now. So, of course, it will be very interesting to see what what's proposed to solve this problem.
I think Dmitry is on the line with us, who did the test for the problem and had some solutions.
I can hear him, but I cannot see him.
Yeah, he's somewhere.
Yeah.
Now hi.
Hey.
Hello, Dmitry. And
hello. So I know that you know how to solve the easy version, right? For the whole score.
And what is your question then?
That's the question. I heard that you know that how to solve the easy version of the problem for the whole score, but do you know how to solve the problem in the hard version?
Well, I can tell you how I approached this problem as a jury. Actually, I think one of the best way to tackle this problem is to start with correct but slow solution, something like a solution which tries every isoform for every read, and well, it will work slowly, but you can be pretty sure that it's not going to have any mistakes. And well, then I think what you should do then is to find some heuristics on how to reduce the search space, because the tests are open. You have like a lot of opportunities to examine them, to try different ideas. When I generated the test, I actually used the simple and robust solution to be 100% sure that like our answer is correct and our answer is the best possible in terms of 8s and 9s test. And I simply just used more computing power that was available to participants. I have used 32, I think, 32 CPUs, a server with 32 CPUs, and of course, it sped up this process a lot. So if you are a participant, you probably don't have such a CPU power, and 30 times times larger than was used in test generation is probably a lot for you to wait. And I think if you have some decent heuristics to apply, it was sufficient to pass here on the full score, to get the full score.
Solved by so many people.
Well, no, actually, I suppose that it should be more hard, but it seems that some people have pretty nice heuristics they came up with. Maybe you will hear from them as they are supposed to join. Try asking them, but I think there are some ideas you can apply, but it's best, I think, to ask the participants.
Yeah.
Thank you, Dmitry.
Thank you very much.
Yeah, it was great having you here. And now I think we have some of the participants waiting for us. And the first one would be James Holt from Hudson Alpha Institute for Biotechnology in Huntsville. And hello, James.
Yeah. Hello, James.
Hello. I was really following you in the scoreboard, and congratulations on your second rank right now. And
Ekaterina was rooted for you. She was just like, James should win. I cannot help that again. Some Russian hackers win the contest. I want James to win.
So, can you maybe tell us a bit about yourself and your background, and like which problem you like the most, and maybe later Alexey and Vitaly will ask some of your solutions, which I'm sure that other participants are dying to know. So, hi.
Sure. So I am James Holt, or I go by Matt usually, and I work at Hudson Alpha Institute for Biotechnology. So we are a not-for-profit research institute in North Alabama, in the United States. Mostly human genetics research, things like that. And my background is actually mostly computer science. Genetics kind of came along after that. In terms of most interesting problem, I really liked the super spreader problem. It seemed very timely, given all the things going on in the world. And it was just, it was a really fun problem to work on, compared to maybe some of the other ones that are more traditional things that you see in bioinformatics.
Were the problems different from the last competitions? I know that you competed in several before. So what was different this year?
I really felt like you guys did a really good job designing the problems to where it was really hard to get a perfect score. In the past, there were a lot of problems that had exact answers that you could kind of not easily, but you could get to the answer, right? That final answer. And these, I felt like there were a lot more inexact answers that you kind of had to slowly build up to get that kind of perfect score for some of these problems. Felt more challenging.
It's great. Yeah, we love the challenge. And
but I think we all are very interested to know, like, how did you solve this problem in particular? I think
which one?
The problem, the first problem. And actually, are you solving similar problems in your line of work, or was it like new for you?
The first problem is genotype imputation. Yeah, just to comment.
I try to avoid imputation actually at work. It's not my favorite thing to do when we mostly work with whole genome data, so imputation is typically unnecessary. Yeah, that problem, that was a challenging problem. I actually ended up kind of just throwing together a gradient boosting model that actually worked pretty well at figuring out and imputing things. I was kind of surprised that that worked, but when I saw it start working, I just kind of ran with it. So that was kind of the way I approached it.
that's cool. So it wasn't some like algorithmic tricks, but actually like
No, it was,
full skill. Yeah.
no, it was mostly just kind of pulling together the nearby locuses and just throwing that into a model, letting it figure it out from there.
Yeah, and I think like and the fifth problem that we just talked about the isoform matching. So like how much time, like how much computational resources did it take for you to solve it? So was it fast or like?
No, that was slow. The first, obviously the smaller ones were pretty easy to run just on a laptop with kind of, my naive first approach at it went pretty well and solved those without too much trouble. But when we got to those, I forget which ones it was, like 8 and 9, which had, I think, 500,000 some odd different things to compare, that I had to start worrying about efficiency and like multi-processing things just to get an answer in time. So that one was challenging. And it really boiled down to, I think I ended up actually pruning the number of things I had to look through with some sort of search. I'd have to go look at my code again. I'm running on empty right now for sleep. So
congratulations for the very good place in the preliminary scores. That was very interesting to look for. Thank you very much, James.
Thank you, and I hope we'll contact you about the prizes after we finalize the results. Thank you for joining us in the contest and here in the studio. Bye-bye. And we have more participants in the waiting room, and the next one, I'm sorry once again if I misspell your name. It's Lucia from National Cancer Center, Singapore, and I hope we will be having the participants on our screen in about several seconds.
Whom will contact us?
It's fifth place.
It's fifth place. The current fifth place.
We will talk about the current. The monitor is frozen, and
that would be really interesting. So it seems the fifth problem was just the computational problem mostly, rather than tricky. However, James told that he somehow pruned their data. That's to be honest, I would like to know how he did that.
Yeah.
Oh, okay. We had our fifth participant.
Hello.
Thanks for joining us, and
please tell us a bit about yourself, where you're from, what's your background, what was like the most interesting problem for you, and...
Okay, so I come from Singapore, and working on a cancer research institute. So, but my background is majorly computer science. I do my PhD in computer science, but I have studied bioinformatics stuff since my undergraduate age. So really not a newbie here, but I think this competition is still new to me because this is my first year. So it's really impressive because I once want to give up, and I always leave behind. I get stuck on almost every problem. And I think I solved some of the problem in a very unusual way. I'm not sure whether they are decided on that purpose, but sometimes I think it's a bit not the standard way to do that. For example, like problem 2 about the mutation, find the location of mutation. I almost find that no need to write any code, just to do the binary search and do manually revise the intervals. So I finally go to that way. I'm not sure whether that is on purpose. This is really a question I want to ask.
Kind of purpose. We definitely tried to get rid of it, but it seems we didn't succeed. That is why you have like logarithm 5 and etc. there, like with sailing and flooring, so like you couldn't do the proper binary search, but we forget the binary search from other ways. So yeah,
Yes,
that's
yes.
a little bit confusing. Like the real intention of this problem were like to get the first approximate answer, and then run the binary search on that to get the best score. So our idea was like that. So like.
So you still limit the time of the submission. That for 10 test cases, there are only 100 times to try, right?
Yeah. That's exactly against that also was done, but it seems it didn't really help.
Yes.
Yeah, and maybe.
What was the most problem that you'd like on this contest?
Sorry. What? Can you come again?
What is the problem do you like the most?
The one I mentioned that don't need code.
The second you like the most?
Okay. The second one probably problem one. That is exciting to me. I'm not really there to start that question very early, so I can only start this afternoon to rush that problem. And I'm really enjoying that the problem has no standard answer, that no exact solution. So there's a lot of way you can just hack on it. Then almost there's maybe no standard things. You can do your creative ways, and maybe you can just give a shock to the problem designer or the organizer. That is for some problem with the exact algorithm to solve all the exact solution, you can never achieve that make the problem designer say, wow, how can do this? This is really a thing that can solve the problem, but I never managed to figure out that. So that may make the competition more creative. I think that is very interesting one. But I am a bit pity that there's no something can like the genetic algorithm do. So I prepared that, but didn't have a chance to use that.
Leave there.
You
alone.
You have.
I have the
a
last
small
question.
One.
Okay. This was the first time you participating in this competition.
No, that's kind. I used to play Google Code Jam, ICPC, but retired in 2012. So after that, I just do research work. Very few time to.
I mean, Bioinformatics Contest. This is the fourth edition.
This one is my first time. Yeah.
Oh, great! Great that you joined.
From where did you heard about that?
I'm not sure. Maybe I see a post on the wall in my school. Probably. I don't remember. I just subscribed many months ago.
Okay. Thank you very much.
Great. And I actually have a last small question. Like, what do you recommend? What can you recommend to those who will participate next time? Like, how should they better prepare? Like, what should they revise? Like, what is your recommendation?
This is really hard to answer. I cannot.
Yeah.
Because you really have a lot of things can do with the problem. So I think any suggestion will just limit your imagination. So no suggestion.
Okay. Great that you joined, and hope to see you next competitions and great result. Bye.
Thank you for organizing. Bye.
Bye. I think we have one more participant. The internet connection there is breaking, so we hope that it will be successful, but if not, we unfortunately won't be able to talk, but let's try.
Yanru, right?
Yanru Guan, yes. And yeah, it's great that several participants have joined us. Yeah, we were a bit worried.
I didn't expect that, to be honest. After 24 hours of the contest, I wouldn't like to talk with anybody.
Yeah, like no sleep, and like we really wanted to make this part interactive, so we Okay. Can you hear us, Yanru? No, no connection. Yeah, our technical team says that there is no connection right now. So if you're among the top 10 and you got an email, or you haven't got an email, you just realized that there is a live stream, then please check your email and try to join us. I think we will continue talking about the problems for a bit, and but we will be really happy to contact you and have you here in our live stream. So yeah, unfortunately there is no connection, and yeah. So I think we can talk a bit more maybe about like the technical realization of the problems. Like Vitaly, maybe you can tell us a bit about the problems creation from the technical side. Like we heard several authors of the problems, how they come up with ideas from their work, but like you get the idea from somebody, and
From
what's
the
going on
technical
there?
perspective, that's...
In a brief.
This is a really hard question, though.
Sorry, yeah.
So what's going on? So we are given, like, our authors of the problems give us kind of raw ideas. Like, they propose the problem and they propose their approximate solutions or approximate scoring. And then we have to understand what is the precise scoring and what is the precise solutions for that we can come up with. So we give the problems to different people to develop, and they, like, we give this like in advance, of course. Of course, in advance. We give this problem to the person and just tell him, okay, so here is the approximate description of the problem. It will be approximate like that. You can change something to make it more formal, or to make it more computer science. So please do this and try to come up with the proper score and the proper solutions. Mm-hmm. Even we do not require the solutions, we just have to require the proper scoring. Mm-hmm. That's the main part of our competition, is that the scoring is very good. Otherwise, like, their contest will not work. And is my experience, their solutions are not necessary.
Yeah, if this problem has no solution, for example, like in a real...
Yeah, no, we even didn't try to solve this on our own. We kind of, okay, we can try to make this here, probably this idea, but we never implemented. We just like, that's
But you tested the problems, like, so that they are solvable, right?
Yeah, we kind of tested. This time we already had the special testing session. Like, we invited some top competitors from ICPC and etc. to solve these problems, and like they because they're not familiar with bioinformatics, it was very interesting to look, were these problems even understandable from their side, and we appeared that all of them were really understandable, with a little bit of frustration from their side. So like they didn't understand it from the first try, but after sitting for 10 minutes or so, they eventually did understand the problem. So like, I wouldn't say that this time the problems were like kind of confusing or something like that. They were pretty understandable.
We had some comments about like the problem statement, and under some steps there were a lot of discussions to clarify, but I think this time it was quite, the comments were quite positive. So thank you, Vitaly, and I think I'm gonna check with our team if we have more participants who are joining us. No, sadly no, but great that we had two, and thank you for taking the time to talk to us. And I think we'll be wrapping up our live stream, and actually, I think for those who are with us in a live chat, you can also share which problem was the most interesting, or maybe which was the hardest for you that you enjoyed or you haven't enjoyed solving. And it would be great to read And yeah, unfortunately, we can't cover all the questions from the chat during this live stream, but we'll try. Our team is collecting them, and we'll try to maybe follow them up in our Sendout or in our social media. And so I think we'll be wrapping up. And first of all, I want to thank the participants for the time you spent like this weekend with us during the final round. Our sponsors, JetBrains, Genetech, Yandex, and Circle. And I think without their sponsorship, this contest won't be feasible. And we hope that we will continue our cooperation and we'll continue having the Bioinformatics Contest in the next years. And
yeah, thank you everybody, and thank you for participating. I hope you'll like that. That's our main intention. So like you have to enjoy the competition even that you didn't get the prizes. I hope that you
even if you struggled, and we really wanted, even if you're not from bioinformatics, we really wanted to show that it can be really fun, and maybe you can look more into this science. We also want to thank the team of the contest developers, and you're gonna see them now on the screen. Without them, it also won't be possible to make this contest. And it's a hard part that sometimes is invisible because everybody is focused on...
Should I say right now the story about how Gennady Karatkevich trained us?
I don't know. Do we have this time? If it's brief, I think we have like 6 minutes.
I think it's brief. I think it's a little bit funny. Like,
okay.
Yeah, so we thought that Gennady Karatkevich won already a lot, and we wanted to decide like how to make him help us writing the problems but not participating. That was very tricky. We thought, okay, he won 2 times, so probably we can do the same as in ICPC. If you want to win 2 times, you never participate in the bioinformatics again. I just go to Gennady and told him, okay, do you mind if we make this this rule for you so that you can help us solving the problem? And he answered me, why do you want to make this rule? You just could have asked me. And like that's great. That's how he decided, like how we make him to help us this year.
So we ask you, like
we ask you this time to help us.
Yeah, help us, and
next year.
Yeah, fill out the form. It's under the YouTube stream, or just write us on the contest at bioinf.me. Write that you have an idea, or you want to participate, you want to join the team. It would make the next competitions better, and please join us. So I think that's gonna be it for now, and I also want to remind you that we are recording this live stream, so you can, if you're late joining us, you can watch it later from the beginning.
Are there any questions in YouTube, probably?
Yeah, I'm checking. I see the suggestion that we need to have a 48 hours final round. That 24 hours.
I will not be able to handle this. Together with Alexei, we just I don't know how much we slept during this time.
Not much.
Yeah, I guess David from the chat saying that we will have then better solutions from participants.
David from the chat, is this David Eccles?
No, it's not a David. I'm not sure I'm gonna say it right. Twice Gombo. I remember comments.
Yeah.
I think that it's really hard to support this long final round. So we decided to have it 24 hours where the participants and the team could handle it.
Yeah, we just even thought that the participants will participate all 24 hours. We just did this to make competition available from every place with the same kind of situation.
Yeah, because of the time zones, it would be fair.
And actually, I think you can write in the chat how much did you sleep during the contest. So.
Yeah, and yeah, I think Vitaly hasn't slept that much as well.
Yeah.
Okay, I think we're gonna be wrapping up.
Yeah, we have to wrap up.
Yeah, it's time is up, and thank you for joining us, and see you soon.
Yeah.
Yeah, bye.
See you.
Bye.